Have you heard of the Big Bang Theory? If anyone has watched the show of the same name, don't be too quick to say yes. We're actually talking about something completely different. Did you know that our universe existed before the Big Bang happened? Watch the video all the way through, and you'll find out why it's no longer considered the beginning of our universe, and how scientists were able to prove it. Are you ready? So, let's get those brain cells moving and go for it. Our universe has been around for a whopping 13,800,000,000 years since the Big Bang happened. That's what was believed until recently. Scientists have long pondered where our universe came from. The greatest minds have tried to mathematically calculate the very moment of birth. The first to do this was American astrophysicist and cosmologist Edwin Hubble in 1924. Amazing, but it's really true. He found out that the universe is constantly expanding. But where did it come from? Another scientist named Georges Lemaître tried to find this out. His background as a clergyman didn't stop him from diving into astrophysics and cosmology. He suggested that the universe was initially a tiny, extremely hot core that eventually exploded and broke apart into countless particles. And that's how the Big Bang Theory came to be, and everything was fine. The theory lived on, and no one challenged it, until the early 1980s when an American scientist named Alan Guth, followed by Soviet physicist Andrei Linda, started asking the question, where did that core come from? I mean, that's a really interesting question. After all, it couldn't just pop up out of nowhere. So they did some new calculations and found out that the universe existed even before the Big Bang, but in a completely different form. Stay tuned, and you'll find out what the universe was like before the Big Bang. Did you know that time machines really exist? Modern technology lets us peek beyond new horizons and see what was happening millions and billions of years before today. It's thanks to them that we can confidently say the universe existed even before the Big Bang. But what was it like? First, let's figure out what the Big Bang is and what it looks like. After the Big Bang, the universe started to expand rapidly. At first, it was in a very unstable state. Can you imagine a blanket where all the cotton has already settled and spread out into dense, separate clumps? Or, for example, semolina porridge that wasn't mixed well and ended up cooking with lumps. Our universe was in a state kind of like that right after it was born. And then the magic begins, as if someone up there tugged on their beard and said, "Takity-be-dak abracadabra." This boiling, gooey mass starts releasing a huge amount of energy, which forms positively charged particles, or as they're called, protons. And that's when the magic happens, like someone up there tugged on their beard and said, "Takity-be-dak abracadabra." This boiling, gooey mass starts releasing a huge amount of energy, which forms positively charged particles, or as they're called, protons. From our 9th grade physics class, we all remember, or if someone doesn't, now they know, that positive particles attract each other and form nuclei. And that's exactly what starts happening. Literally 20 minutes after the Big Bang, a whole field of hydrogen nuclei appeared. Just imagine how crazy fast it was. Watch below to see how miracles happen on the bends when something is born out of nothing. The universe after the Big Bang was like poorly cooked, boiling semolina porridge with lumps. The dense clumps attracted more and more matter and energy as the universe gradually cooled and expanded. And the goo, on the other hand, was giving off energy to those very clumps. This is the cycle of energy in nature, which will soon turn into a multitude of galaxies and stars. Today it would be called the World Wide Web. It's the irregularities that give rise to new planets, stars, and galaxies. This has been proven by various studies in astrophysics and cosmology. It's only because of the universe's imperfections, its not ideality, that our galaxy, the Milky Way, and we exist today. Everything that scientists are discovering in space now came from those various lumps of semolina in the universe billions of years ago. Today's stars, nebulae, and clusters of galaxies can be traced back to the first tiny imperfections in density that arose when the first atoms formed in the universe. This process of atom creation was explained back in the early 20th century by Mr. Einstein, who developed the theory of relativity. He called it gravity, or the ability of objects in matter to attract each other. And the most interesting thing, friends, in his theory is that when there's too many clumps stuck together in one density, it slows down time. And this is a real black hole that you can enter, but from which you can't escape. Stay tuned, and you'll find out why we live as if we're in a microwave. The Big Bang was so powerful that its remnants are still wandering through our universe. They're all at different temperatures, some are warm, and some not so much. This is what's called the cosmic microwave background, the residual glow of the Big Bang, first discovered in 1965. It was extremely difficult to find it because its temperature is almost zero. The clue to how they managed to detect it lies in the word almost. The zero turned out to be not absolute, but with a tiny deviation towards plus. When scientists first detected it, they did not even understand what was actually happening. They thought the equipment was malfunctioning. As you can see, everything turned out to be in order with the equipment, and we were presented with a new scientific discovery. Deep space isn't absolute zero. As the universe expands, scientists will need more powerful instruments in billions of years. As our universe continues to expand its horizons and cool, in a couple of billion years scientists will need even more powerful instruments to detect it. And then the mysteries of the universe's beginnings will be completely shrouded in darkness. For now, let's enjoy the cosmic scientific discoveries. All the temperature fluctuations are just the aftermath of the Big Bang. The young universe, like freshly cooked semolina porridge, was gradually cooling down. About 380,000 years ago, its temperature became comfortable for the formation of hydrogen atoms. The universe became practically transparent and no longer scattered light. It's on fire. Stay tuned, and you'll find out what drove scientists to dig deeper when everything seemed to be known. So, by the early 1980s, scientists realized that the Big Bang model, despite its elegance and undeniable alignment with the actual state of the universe for most of its existence, still needed some adjustments. So what does it take for that? Of course, new hypotheses and calculations. And this is where a whole brainstorming session kicks off, which ultimately led to the idea that maybe our universe existed even before the Big Bang. But what could have led to such a hypothesis? If we assume that at the very beginning of the universe's formation there was a field with negative pressure, then a lot of what was previously proven starts to look completely different. If you think that negative pressure doesn't exist, you're very mistaken. Let's take two examples, one with positive pressure and one with negative pressure. Compressed gas has positive pressure because it loses energy and cools down when it expands. An elastic band, or simply a rubber band, on the other hand, has negative pressure. After it's stretched, it compresses. When we stretch a rubber band, it heats up, and when it compresses, it releases heat. The same thing happened with the universe when it started expanding. The fields with negative pressure were accumulating heat and then heating up the entire universe. Interesting hypothesis, isn't it? But, what if this version is true? What if the universe started expanding even before the Big Bang? Stay tuned, and you'll find out how scientific hypotheses turn into reality. It is difficult for someone who does not have a mathematical mind and is far from the basics of physics to imagine all the scientific calculations of astrophysicists. Their world is one of calculations and dry figures, complex concepts, and confusing theories. It is extremely difficult for us mere mortals to understand all these subtleties. But let's try to understand why the idea of negative pressure fields in the universe became the starting point for the theory that it actually existed before the Big Bang. Let's assume that the radius of the universe was initially larger than the smallest segment of space where modern physical theories apply. It's 10 to the minus 32 meters. That's very small, but by the time the universe has expanded to its maximum, its length will be at least several thousand light-years. As a result, all changes will lead to the space becoming absolutely flat, without any imperfections. If we assume that in the very beginning there was a tiny bubble instead of the universe, then as it grew, heat built up inside it until it got too hot. Then came the Big Bang, after which the universe keeps expanding and cooling down. At its maximum expansion, the horizon ceases to exist because you simply can't see it. Stay tuned, and you'll find out that the path of astrophysicists to the stars is paved with challenges. At its maximum expansion, the horizon ceases to exist because you simply can't see it. Stay tuned, and you'll find out that the path of astrophysicists to the stars is paved with challenges. In the early 1980s, several astrophysicists proposed the theory of the universe's existence before the Big Bang, when it gradually expanded and heated up from a tiny point. Then came the Big Bang. It's worth making a small correction here. In modern cosmology, it's commonly accepted that the Big Bang marks the emergence of the hot universe, meaning the end of its expansion and heating. and the beginning of what's called the peak of high temperature. The first person to put forward such a theory was the Soviet and Russian physicist Alexei Arabinsky, but his work remained unnoticed until a certain period. The global astrophysics community favored the work of American Alan Guth. He believed that there are several universes in space, like poorly cooked semolina porridge with lumps, constantly colliding with each other and releasing energy in the process. In the end, the cosmic space becomes exactly like that. Now, here comes the Soviet scientist Andrei Linda, who builds on Alan Guth's theory. He confirms that the universe was born from a vacuum bubble, and all the irregularities and lumps inside it stretch and smooth out as it expands. At the same time, the temperature is rising, so, in the end, we have a flat, hot universe that then evolves according to the Big Bang scenario. Linda shifted the date of its emergence to about 10 to the power of minus 34 seconds, and that's already a pretty precise result, close to the beginning of our universe. Think about it, please, just step back from here, and this is already an almost exact result, close to the beginning of our universe. Think about it, please, step back from here. Stay tuned, and you'll find out what chaotic inflation is. Chaotic inflation is the scenario of the universe's evolution from a state of semolina porridge with lumps to an absolutely flat, dense, and hot state. Why is it chaotic? Because the lumps in it are not arranged in order, but rather however they please. The state of the universe at birth was very unstable. Imagine our modern monetary inflation, where prices are skyrocketing at a cosmic speed. The same thing happened with the universe, only it was much faster. In just a fraction of a second, it grew from a tiny bubble into a dense and very hot ball, after which the Big Bang actually happened. The most interesting thing about this theory is that this process doesn't happen just once, but constantly. In the cosmic space, there are countless vacuum bubbles with different densities inside. And where one universe forms, another one follows right behind it. And it goes on forever. This self-reproducing infinite process gives rise to many worlds, which are called the multiverse. They're all completely different and can evolve in various directions. Each new galaxy will differ from the previous one in its composition, birth rate, and further development. That's what makes Andrei Linda's theory so unique. Read on to find out why the chaotic inflation theory is considered the best. The theory of chaotic inflation explained many processes of the formation of the universe before the Big Bang. So far, no one has been able to disprove it. Modern astrophysicists and cosmologists are making a truly scientific revolution, trying to understand the process of formation of multiple universes. As one of Andrei Linda's articles states, the cosmos is made up of a huge number of inflating spheres that give rise to similar spheres, which in turn create even more spheres in ever-increasing quantities, and this goes on forever. The theory of chaotic inflation became the most progressive not only for its time, but also in the modern world. It's still far from being complete, as there's no explanation yet for what kicks off the actual process of the universe's expansion. But everything suggests that we're moving in the right direction. And maybe soon we'll be in for some new discoveries. The universe holds many secrets. Maybe someday we'll be able to unravel the mystery of its birth. And that will be a completely new story. Hey friends, I have a business proposal for you. Do you want to join our team? If you have video editing skills, can voice over videos in Russian, English, and other languages, or if you write interesting scripts, we would be happy to work with you. Message our Telegram bot, the link is in the description. And that's all for today. Good luck, everyone.